Students, good evening. Today, I am going to solve one more problem. This problem is entirely different from the previous one. In the previous problems, the inlet and outlet temperature. Inlet temperature is given, outlet temperature is a question mark. In this problem, both inlet and outlet temperature for both stream are known. Unfortunately, the mass flow rate of one stream was unknown. We have to find that. The problem is a heat exchanger is employed to cool the oil from a temperature of 150 degrees Celsius to 50 degrees Celsius. The process is oil is getting cooled down by using water at ambient temperature. The mass flow rate of water is 4000 kg per hour. The ambient temperature is 20 degrees Celsius and the exit temperature of water is 130 degrees Celsius. The average specific heat of oil and water are 2.5 kilojoules per kg degree Kelvin. Similarly, 4.185 kilojoules per kg degree for water respectively. The question is, determine the changes in entropy of the total system. Total changes in entropy as well as work lost. This is the question mark. In this problem, a heat exchanger is employed. Oil enters at a temperature of 150 degrees Celsius. 150 degrees Celsius, that means plus 273.15 degree Kelvin. 273.15 degree Kelvin. Hence it will be 3.15 to 423.15 degree Kelvin in terms of degree Kelvin. The exit temperature of oil is, what is this? 50 degrees Celsius. 50 degrees Celsius. So 273.15 about 323.15 degree Kelvin. This is the exit temperature of oil. Water at ambient temperature gets circulated in order to decrease the oil temperature. The entering temperature of water is 20 degrees Celsius. That means 293.15 degree Kelvin. The final temperature of water is 130 degrees Celsius. So 273.15. So they are about 403 or 0.15 degree Kelvin. So initial temperature and final temperature are given. The changes in temperature dT for oil is initial temperature 423.15, final temperature 323.15. So 100 degree Kelvin dT for oil. Similarly for water, dT for water is equal to final temperature 403.15 degree Kelvin, initial temperature 293.15 degree Kelvin, hence it is 110 degree Kelvin dT for water. Clear? Right, okay. Heat capacity of oil as well as water. Heat capacity of oil is 2.5 kilojoules per kg degree Kelvin, and similarly heat capacity of water 4.185 kilojoules per kg degree Kelvin. These data are given. Mass flow rate of water, m dot, for water is given. It is equal to 4000 kg per hour. Mass flow rate is given. And mass flow rate of oil is the question mark. In order to find the mass flow rate of oil, we have to perform the energy balance equation between oil and water. Energy balance equation, mCp dt is equal to mCp dt. This is for oil, this is for water. Clear? This is for oil, this is for water. Water mass flow rate is known, heat capacity is known, difference in temperature is known. Similarly for oil, Cp is known, dt is known, unknown is mass flow rate. That means m dot Cp dt divided by Cp dt is equal to mass flow rate of water is 4000 kg per hour. Cp 2.5 kilojoules per kg degree Kelvin. and difference in temperature for oil 100 degree Kelvin divided by Cp of water 4. I'm sorry, this is yes, this is Cp of oil, this is Cp of water. Cp of water 4.185 into difference in temperature 110. Similarly for oil, Cp of oil is 2.5 kilojoules per kg degree Kelvin and difference in temperature is for oil it will be 100 degrees Celsius. So mass flow rate of water after performing this calculation, mass flow rate of water is 7365.6 kg per hour. So mass flow rate of water was established by using energy balance between oil and water. Clear? Okay. So mass flow rate of oil is equal to 7365.6 kg per hour. Next, I am going to find the entropy change. Entropy change. Okay. Changes in entropy of the oil. Here, del S oil. In order to find this one, changes in entropy, second law of thermodynamics says that ds is equal to dq by t. ds is equal to dq by t. dq is equal to cp dt or cv dt. This is a open process. Oil enters at one end and leaves to another end. So pressure is constant. So this process is constant pressure process. So dq is equal to cp dt. Substituting this one, ds is equal to cp dt divided by t. For a known mass flow rate of water, for a given mass flow rate of water, given for a given mass flow rate of substance, this equation becomes ds is equal to m dot cp dt by t. This is the equation to find the changes in entropy of the substance. Okay. Now I am going to find the entropy changes in oil. Entropy changes in oil. So m dot cp dt by t. M dot value. There. This is ds. It should be written in terms of ds. ds changes in entropy oil. So mass flow rate of oil just now predicted 7365.6 kg per hour. Kg per hour into Cp of oil is 2.5 kilojoules per kg degree Kelvin into, on differentiation this will be 1 by t into dt. So ln final temperature to initial temperature. Now I can write this finite changes in entropy. Once if you are taking integral, it should be finite difference. So initial temperature, what is the initial temperature? It will be 150. That means 423.15 degree Kelvin. 50. 323.15 degree Kelvin. What is the answer? So kg gets cancelled. For 1 hour, you have to assume that the basis of the problem is 1 hour operation. 1 hour operation, hence this hour gets cancelled. The answer becomes minus 4980.9 kilojoules per degree Kelvin. Changes in entropy of the oil. What next? Changes in entropy for the water. Again the same equation. Finite change in entropy of water is equal to m dot cp dt by t. That means ln T2 divided by T1. Find this. So mass flow rate of water is 4000 kg per hour. This is 1 hour operation, hence it is kg. Cp of water 4.185 kilojoules per kg degree Kelvin into ln the initial temperature 20 degrees Celsius to 130 degrees Celsius. 130 means 273, 303 and 403. 403.15 to 20 degrees Celsius. 293.15 degree Kelvin. The answer is equal to, for water, 5330.91 kilojoules per degree Kelvin. So total entropy change, total entropy change is oil plus water. This is minus 4980.9 plus 5330.91 kilojoules per Kelvin. The answer is 350.01 kilojoules per degree Kelvin. This is the total entropy change. What next? Amount of work loss. Amount of work loss. The equation to estimate the amount of work loss is sink temperature TL into total entropy change. Total entropy change. Sink temperature, that means entering temperature of water is 20 degrees Celsius. In terms of Kelvin, 293.15. 293.15 into 350.01 kilojoules per Kelvin. This is kilojoules per degree Kelvin. This is Kelvin. Kelvin gets cancelled. The answer is 89,413. 89,413 kilojoules. This much quantity of energy gets lost during this heat exchange process. This is the amount of work lost. Thank you.